As I start packing away stuff, a couple projects then long ago come to mind. This is a LED torchlight, intended LED torchlight from 2004, long before LED torchlights was on the market. It didn't have anything at least available locally here. It wasn't really even properly developed. Super bright LEDs was just coming on. It was mostly hobby stuff, no products, nothing of the sort. This is the second iteration. As I said, the first iteration was one that was shaped by this 1.5 inch aluminum. Inside here had a plate that was interference fit machine and the LEDs in here. I can't find back this one. I've machined out this to put a bright probably 3 or 5 foot LED straight on the aluminum base because it's a really excellent heat sink, and I did so. It doesn't work actually now because it was machined out, but I can't find it. Anyway, so straight then I tapered into this. Coming across, it was a 4-cell light, so it was longer than this. This is 3-cell, right? And the back of it, what I did with it is threaded the tubing, then made a first threaded piece that basically screws in and pushes against the batteries inside here. And that tubing basically had a spring push against the tube. Inside of that tubing, there's a PVC sleeve pressed in, so that screws straight down and touches onto this and touches of course the threads. This PVC sleeve was also threaded, and there's a second, right, basically what you call that, aluminum piece similar to this. They were both about the size, right? So first aluminum piece, you tighten and you tighten it. This spring was pushing onto this middle bar that comes in here, so it doesn't touch this one. It touches the negative of the batteries. Then now when you screw this down, and this piece here touches this side here, and of course this is touching here and the threads are touching, you get the negative contact, and that was the switch. So essentially foolproof switch, cannot break, cannot, I mean, you really can't break this. That's not a mechanical piece to break. And if these threads ever get a little loose, nothing like a little thread seal to tighten these things up and make it work. So this was the initial one, and this is the more advanced version. The knurling on this one had a bit of knurling on it. If you don't know what knurling is, this is knurling, this finish. The knurling on it didn't come out good. Knurling is a technical thing. Sometimes it double runs, so it runs the first time and creates a knurl, and then it runs over and creates a knurl half the size. It got really fine, so knurling wasn't that great. This was much more advanced. Hopefully it's showing good in the light, the sun is going down, but the knurling on this is fairly good. If you have a look, you could see it's reasonably good. Some metal thing I had here that seems to have left some corrosion on it. The knurling on this piece was pretty good. There's a hole in here for suspending. I see there's a little piece of nylon wire that was there from whenever it was built to hold it inside the solution. The reason it's not so dull is it was electroplated, and that's what the reason this wire is here for. This wire was connected straight inside with silicone onto the inside surface here. I don't think you could see that well. Let me put on the light in this and put it back on. Now with the light, hopefully the knurling is readily apparent. And getting back to what I was on now with this thing, if you look inside here, you'll notice that's a color. It's a very nice blue color. Some places a little darker than others. This was the days when I was experimenting with anodizing and coloring, and actually it isn't that hard. It really is just sulfuric acid. You put on battery onto this, it gets an oxide coat. You clean it really well, obviously, up front. You get an oxide coat, you dip it in food coloring, anything. This was actually closed dye, a navy blue closed dye, and it took it up. Some of it didn't come out that good, and I re-etched it. So normally what you do is you hit sodium hydroxide first, lye to get this whole thing stripped down, get rid of all your oils, everything else. Then we go into sulfuric acid, put a battery on it, get an anodized coating, suspend it, hence the reason have this little piece here, suspend it because you don't want it touching anywhere. And then after, what you do is you put the color in and supposedly boil it. That's supposed to have had the oxide. I didn't try boiling, I didn't see any difference, but so this was my contact, my lead. and it was stuck in and soldered in here. And this silicone was to protect, the intention was to protect the contacts inside here that was already in. There's already a piece of plastic in here and a contact, so that was to protect it from corrosion. And this second iteration, this was the switch. So I had a push button switch on, off at this, that was already selected, correct size and everything else. This is drilled step, so basically the switch would have fit in and epoxy in, and that would have worked. And there was already a flat plate machine for here, and that would have been a plexi plate that would have fit over a flat LED in here. This is still perfectly valid, still perfectly viable. The finish here, not the greatest. Could do better, could do better. Nice curve machine finish. This is what basically grinding a file and getting the profile and then running it up, because you do this with a lathe just so it's not that simple. This rubber is not the ideal rubber, but it was meant to basically tighten and hold this in here to keep this from the acid from going in and corroding the contacts. Let me open this and show a little bit inside, and that's pretty much going to cover it, but let me show a little bit inside and discuss this a little. Right, having a look at the, well, there's a rubber seal, and obviously, let me see if I can knock this off a little. Right, we can see past it. Well, I threaded up to, cut in a little bit, threaded up to it, and as you can see, it got anodized a bit, and you could see a color. It was a green. I tried green before on this, and that didn't work out really well. This could have been a little bit better finish, but yeah, drilled in, threaded, and then let's look at the tube, threaded, and if you look quite down on the bottom there, you could see that piece of brass in a piece of PVC, and that is what I was trying to protect with the silicone there. You could see it. Right, this here again, threaded piece. What I want to talk about with this is 1/2 inch aluminum pipe, schedule 80, and it's absolutely perfect fit for a AA battery. Let me get one, let me drop it in and show you. The long of Torchlight was really amazing. Basically it was so tight it would fall in slowly, and the air pressure keeping it back, but not tight enough to stick. So let me get a AA and try it and show how well this goes into here. I'm back with my AA, so let's have a look and show how brilliant this is. It's amazing how well it fits. So this goes in here, watch this. See how slowly that goes down, but it doesn't stick. If I just shake it, it's back out. And this is really the absolute perfect size, right, for AA batteries. That said, it is nearly impossible to get schedule 80 aluminum, 1/2 inch aluminum pipe anymore. I've tried, I really tried. I got a set and built these 2 Torchlights, and I've been looking and I have not been able to find this. So if you're fortunate to find it, and you know, it's really the perfect size for this kind of batteries. That said, these days now I would not have built a Torchlight this size anymore if I'm building this today, simply because the 18650 form factor lithium ion batteries are easy, they're cheap, they give 3.7 volts, which was one of the major problems with this. The reason that this one actually only had 3 is I was going with these batteries, whereas, well, not this particular one because any loop wasn't in the market, but you know, rechargeable batteries. The 4 one was just to be sure that I got the correct voltage with rechargeable batteries. That's 3.6. You know, as soon as it starts to go down, you go under the 3, and then the 3 volts as required for the white LEDs, it fails. So 4 was the safer bet, which is why the next one was 4. This one I said, this is what I had, this is what I had available, let's make it 3. But now I wouldn't do this. Now I would look for something to fit into the 18650 batteries, and just have one battery this size, and you know, just be able to pull a lot more power density, weight, you know, ease of doing it. It's much easier. But again, just for documentation. So this is how it looks. Documentation, nailing, then days when I used to do a bit more of machining, a little less electronics. It changes over time.